Hello guys, get your iPads out and we're going to continue our notes. Today I will speak through the notes and then I will pause for you guys to write them down. I'm going to try and regulate each slide at 2 minutes so that we can get through them. This video will be posted on my website so you can always click on it later on if you need to fill in any slides. Alright, so let's begin. I'm going to read it down. The limitology. Guys, this is the study of bodies of fresh water and the organisms that live in there. So each lake or pond is going to have an ecosystem, and there are different scientists that want to break it out and study the nearshore environment. That would be the part that you could probably just reach in, step into. You're going to have the photic zone, which is going to be out in the open water. So let's say you're paddling around in a watercraft. Any part that you could easily see, or basically where light could penetrate, we're going to call that the photic zone. And then the deep water, that's where the sunlight doesn't penetrate. So think deep or dark. I would think deep, dark, should sink into your mind. So again, the littoral zone, that's the near shore environment. The photic, where light is going to be able to penetrate, and then the deep water, dark, that is going to be the lower portion. Use this time to finish copying down those notes. As I mentioned before, if this isn't enough time for you to finish the notes, feel free to check out my website and you can watch this video again on your own time. Also, if you finish the notes quickly, feel free to swipe over to your vocab and continue working on that. Once we finish this video, you'll complete the rest of the vocab with the time remaining in class. So wetlands. We discussed yesterday in the Do Now the difference between a marsh and a swamp. Marsh and swamp are both types of wetlands. So wetland, land where saturation with water, right, is the dominant factor determining the nature of the soil development and the ecosystem. That's again third time that we've talked about ecosystem. The ecosystem living in the soil and on its surface. So if you guys remember, we talked about estuaries. We just talked about the limnology and looking at the ecosystem living in ponds and lakes. And now wetlands actually have their own ecosystem. So to break it down a little bit further, the marsh, remember that's going to be the shallow wetlands, and it's going to have the absence of trees. Those are the big things. So make sure that you highlight stuff like that. Alright, that is terrible highlighting. But you guys get the idea. So again, utilize this time. I'm going to give you about 2 minutes to try and write most of this slide. Okay. So, back to streams and rivers. Right? Streams and rivers are the most powerful weathering and erosion force on Earth. Streams and rivers are actually responsible for carrying a lot of that material from higher elevations down to sea level. We're going to learn later in this chapter that the ocean is the ultimate base level, the point where that erosion stops. But all along the way, every time rock breaks down and is carried by water, we're looking at streams and rivers to do the bulk transport. However, the ability of a stream to transport sediment really is going to be dependent on velocity. How fast is the water moving? Now, the velocity has some other factors. So we're going to talk about gradient. You guys may know gradient from when we talked about topography, but that's basically slope, the change in elevation or the change in distance. The steeper the gradient, the faster the water is going to move. So again, that's going to be a factor back on velocity. The discharge is the actual volume of water that's going to be moving at a given time past a certain point. So they're going to, just like velocity, look at how far you've gone and how long it took you to go that far. Discharge is how much water has passed a particular point in the given time. The last thing here, we have the note that says the shape of a stream's channel. And we're going to get into that in a second, but just be thinking, well, if it's a straight channel, well, the water's going to have less resistance. It doesn't have to turn. So the water's going to move a little bit faster. That tends to be in higher elevations. Whereas if you have the meanders, those bends that we saw in the diagrams yesterday, that's going to cause the water to move a little bit slower. And again, slow, when we're discussing fast or slow, we're discussing velocity. So go ahead and finish this slide. I'm going to give you a little over a minute to do that. Just as a note, the next few slides have velocity, gradient, discharge, and an explanation of the stream channel. So let's keep going. So here you have the definitions for velocity, gradient, and discharge. Velocity is the distance that water travels in a specific amount of time. Right? So velocity in physics, you'll learn, is distance over time. Gradient, as I was just saying, is the change in elevation over change in distance. So this definition describes it as the vertical drop of a stream over a given distance. You'll notice that in both of these we're trying to talk about water, the whole theme of the chapter. A steep gradient increases a stream's velocity. Now, if you think about walking down a hill, if the hill is really steep, you're going to walk a lot faster than if it's gradual, right? Semi-flat. And then discharge. The amount or volume of water that passes a given point in a specific time. So again, here you're talking about some type of rate. So I like the little statement down here, rate at which a river flows. That's discharge in a nutshell. Okay, I'll give you 2 minutes to finish this slide, then we'll continue. Alright, gonna change slides. Remember, you can watch this video on my website and fix your notes. So the stream channel, the path in which water flows. That's the simple definition. Then I gave you the italicized version. This is a little bit more detailed, right? An open conduit that consists of a stream bed and bank that act to confine the flow. So if you think about a conduit is like a tube, well then a stream channel would be cutting the top of that tubing off, but it's still confining the flow. A meander, remember that's going to be the bend in the river. We said before that that's going to slow the velocity. Whereas a straight channel, you're going to have a faster velocity. It's kind of like trying to walk down the hallway. If you got to walk around all the people that are congregating outside their lockers, it takes a little bit longer to get down the hallway. And then some other characteristics. The shape, the size, the roughness or smoothness of the surface. And remember we talked about laminar flow and turbulent flow yesterday. Alright, take 2 minutes on this one. Alright, I might be jumping the gun a little, but remember, you guys can always go back. So, if you look here at this diagram, it's showing you different ways that a stream's actually going to be able to transport material. Right? Remember that, as I said at the beginning, a stream and a river is going to be a major erosional agent. Right? This is really how you're moving so much material. So this diagram, again, you guys can find on Google, but right, the flowing of the stream is going to pick up and transport material, and that really is erosion in a nutshell. So when you look across this diagram, you're going to see dissolved load. That's where ions are actually dissolved in the water. Suspended load is when you have clay particles that are dissolved or being temporarily carried in the water. And then you're going to have the bed load, and those are all those pieces of rock sitting along the floor of the stream or river. Okay? So, stream erosion. You guys are just going to finish off with this slide. So as I just said, there are really three ways that you're going to transport. The dissolved load or solution, the suspended load, and the bed load. So dissolved load are when you're going to have ions that are actually dissolved into the water, and that's kind of like having a glass of salt water. You can have no velocity, but still have salt water. Whereas if we took that same glass, we empty it out, fill it with water, and then put some clay and silt, stir it up, it's going to get all murky, right? It's going to be muddy water. And that muddy water, if we leave it, maybe we come back the next day, all that sediment will settle down to the bottom once the velocity reaches zero. So that's what we call suspended load. It's temporarily sitting in the water. Bed load, on the other hand, is when it basically gets pushed along the bottom of the stream. It might skip along with what we call saltation, but primarily it just gets pushed along slowly and really takes a lot of velocity to make it work. So go ahead and finish dissolve load. This slide should only take you another minute. All right, so dissolve load, the next one would be suspended load. Key points here: small sediment that remains suspended in a river's water. Remember, as I said, this would be like having clay and silt mixed up in a glass, but once the velocity reaches zero, slowly that material is going to settle out. One more slide, guys. And then you can go hit that vocab. Make sure that you complete that. I'm going to ask you to turn that in Monday at the start of class. All right, and last slide. I know, whoa, all those words. As I said before, the bed load is a sediment that's going to be carried along the bottom of the channel. These are going to be the rocks, the boulders, the cobbles that really take a lot of velocity to be able to move them. So you might get rolling, sliding, and saltation. Now saltation's kind of cool. This is a bouncing or skipping along the bottom of the river or stream channel. So I'm going to let this run for another 2 minutes. And then once you guys finish this slide, change over to your vocab and finish that up. Remember, this weekend you're going to have your first comp review assignment. Please put the effort into it, and that will help you to prepare for the end of the year. It is random. It hits different chapters, but it really is intended for you guys to get that reinforcement now in April, so that as we move through the rest of April and into May, you guys are thinking back on material that we did in September and October. So do a nice job, and that has to be turned in by Monday morning. All right, well, to my colleague, thank you for covering my class. To the rest of y'all, enjoy Pep Rally. Go Firebirds.